Pricing electrical work for shed wiring involves several components, including ditch digging, wiring the electrical panel, and installing outlets and fixtures. For ditch digging, you have two primary options: firstly, charging per foot, and secondly, charging by the hour. When charging per foot, a common rate ranges from 50 cents to $1 per linear foot. This price should encompass labor, materials like polyvinyl chloride pipe, dirt removal, and equipment costs. This method is suitable for straightforward ditching tasks. Alternatively, charging by the hour can be more appropriate for complex or extensive ditching projects. Hourly rates typically range from $75 to $125 per hour. If the ditching work is particularly challenging or necessitates specialized equipment, consider charging a premium on your standard hourly rate. When it comes to wiring up the 4-circuit panels, there are a couple ways you can charge as well. Firstly, consider charging a flat rate per panel. A reasonable range could be $250 to $350 per panel. This flat rate should cover the basic labor involved in installing the panel. Secondly, calculate the cost of all materials needed, such as the breaker panel, wiring, and any other necessary components. Then add your labor cost, typically calculated at an hourly rate between $75 and $125. This approach provides a detailed breakdown of costs. For pricing outlets and fixtures, consider firstly charging a fixed amount per electrical box opening used for outlets, switches, or fixtures. Typical rates are $10 to $20 per opening. This method is simple and easy to communicate to clients. Secondly, calculate the cost of materials, including boxes, devices, wiring, and other related items. Add your labor rate, again typically between $75 and $125 per hour, to cover the installation work. To ensure your pricing is competitive and fair, research local market rates and consult with other industry professionals in your area. Understanding the prevailing rates will help you stay competitive while maintaining profitability. Always provide a written contract that clearly outlines your pricing structure to the customer. This will prevent misunderstandings and ensure transparency throughout the project. Here's an example calculation for a job involving 100 feet of ditch digging, wiring 4-circuit panels, installing 10 outlets, and installing 5 fixtures. For ditch digging, at a rate of 75 cents per foot, the cost would be 75 cents multiplied by 100 feet, totaling $75. For the 4-circuit panels, at a rate of $250 per panel, the cost would be $250 multiplied by 4, totaling $1,000. For the outlets and fixtures, assuming 15 total openings at a rate of $15 per opening, the cost would be $15 multiplied by 15, totaling $225. The total cost for this example project would be $75 plus $1,000 plus $225, equaling $1,300. Remember that this pricing is just an example and may need to be adjusted based on specific job conditions, the complexity of the work, and local market factors. Be prepared to modify your pricing based on these variables. Finally, let's dive a bit deeper into the electrical aspect. When installing a 4-circuit panel, it is important to understand the load calculations. These calculations determine the appropriate size of the breakers and wiring needed to safely handle the electrical demands of the shed. First, identify all the electrical devices that will be used in the shed, including lights, outlets, and any appliances or tools. Determine the wattage or amperage of each device. Next, calculate the total load in amps by summing the amperage of all devices. Be sure to account for any continuous loads, which are loads that operate for 3 hours or more. The National Electrical Code, or NEC, requires that continuous loads be multiplied by 1.25 to account for the increased heat generated by prolonged operation. Once you have calculated the total load in amps, select the appropriate size breakers for each circuit. The breaker size should be matched to the wire gauge to prevent overloading and potential fire hazards. Consult the NEC Table 310.15b16 for the allowable ampacities of insulated conductors. When running wiring in underground PVC conduit, ensure that you use the correct type of wire. THWN or THHN wire is commonly used for this application as it is moisture resistant. The depth of the underground conduit is also important. Typically, it needs to be at least 18 inches deep to provide adequate protection from physical damage. When connecting to the main electrical panel, make sure to follow all applicable codes and regulations. Use properly sized wire connectors and ensure that all connections are tight and secure. Label each circuit breaker clearly to indicate what it controls. This will make it easier to troubleshoot any electrical problems in the future. Regarding outlets, there are several types to consider. Standard 15 amp outlets are suitable for most general purpose applications. However, if you plan to use power tools or other high demand devices, consider installing 20 amp outlets. Ground fault circuit interrupter or GFCI outlets are required in damp or wet locations such as outdoors or in areas where water may be present. These outlets are designed to protect against electrical shock by detecting ground faults and interrupting the circuit. When installing lighting fixtures, choose energy-efficient options such as LED lights. LED lights consume significantly less energy than traditional incandescent bulbs and have a longer lifespan. This can save the customer money on their electricity bill and reduce the need for frequent bulb replacements. When wiring switches, be sure to follow the correct wiring diagram. A standard single-pole switch is used to control a light or outlet from one location. A three-way switch is used to control a light or outlet from two locations. Make sure to properly identify the line, load, and neutral wires and connect them to the correct terminals on the switch. Consider smart switches that can be controlled remotely via a smartphone or voice assistant for added convenience. These switches allow the customer to turn lights on or off, dim them, or set timers from anywhere. Surge protection is another important consideration. Surges can damage sensitive electronic equipment. Install a surge protector at the main electrical panel to protect the entire shed from voltage spikes. Consider using surge protective outlets for individual devices. Make sure the shed is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. Connect a grounding electrode, such as a ground rod, to the grounding system in the shed. Also, ensure that all metal parts of the electrical system, such as the panel enclosure and conduit, are properly grounded. Finally, after completing the wiring, thoroughly inspect all connections and test the system to ensure that it is working properly. Use a multimeter to check voltages and continuity. Verify that all outlets and switches are functioning as expected. With these considerations in mind, an electrician can perform shed wiring projects safely, efficiently, and in compliance with all applicable codes and regulations.